Well, hello everyone. My name is Amanda. I'm from the Green Bank Science Center, and I'm excited to be here with you today and to pilot a new series commemorating the 20th anniversary of the Robert C. Byrd Green Bank Telescope, the largest fully steerable radio telescope on the planet. In this series, we will be recognizing folks who were crucial to the planning, building, commissioning, and maintaining of the Green Bank Telescope. I'm particularly excited to kick off this new series with Dr. Mark McKinnon. You are currently the Assistant Director of New Mexico Operations for NRAO, the National Radio Astronomy Observatory, and on the other side of the country from us right now. Is that right?
That's correct.
So as we'll have others talk more about, the need for the Green Bank Telescope was brought about by the collapse of the 300-foot telescope here in Green Bank in November 1988.
I was a student in New Mexico at the time, and it was quite the talk of the town. It was a big shock for the radio observatory, but it led to bigger and better things in Green Bank. I joined the Green Bank staff as a postdoc in 1992. 2 years later, I was fortunate enough to be offered a job on the permanent scientific staff. The first things I did when I was there, I scheduled the 140-foot telescope. I also did some user support there at the telescope. I also helped with the administration of the National Radio Quiet Zone and did some RFI monitoring.
So construction had already started by the time that you got around. So you actually at least got to see part of that process.
That was fantastic. It was just spectacular to watch the thing being built. And I was very lucky. Around 1997, I was asked to join the project to be responsible for the coordination of all the NRAO activities, outfitting the telescope and writing its commissioning plan.
From what I understand, your role to have been was bringing a lot of different working groups together and seeing projects to completion for the Green Bank Telescope. Just generally had your hand in a lot of different projects during that time.
Yeah, so the project was kind of divided into two big parts. Of course, the biggest part was the construction of the structure itself. And then there was NRAO's part, which was hardware and software that makes a structure into a working radio telescope, as you've alluded to. So it was the receivers, the local oscillator intermediate frequency system, the GBT spectrometer, which was the main recording instrument. There were laser range finders for the telescope, an active surface, one-of-a-kind thing that was very impressive. And then, of course, the monitor control software that had to make all those things work together.
I've learned just from my role here as a manager at the observatory that getting a lot of different entities to work together and come together can be a big challenge. And I'm sure
Yes.
Bringing a state-of-the-art scientific instrument to fruition in itself is a big challenge. Can you tell us a little bit about maybe a challenge that you faced and how you were able to overcome that? I know you mentioned the track, but anything that comes to mind?
There are a couple of things that come to mind. One, I mentioned the active surface, and first off, I was just the coordinator and communicator, and there were some really smart people did the heavy lifting on getting this work done. And on the active surface, that was a really impressive piece of work. In 2000, things really got exciting because there was a lot of pressure to complete the telescope. It was obvious that the construction was nearly complete. Everyone knew it now was our turn to get involved. We had a very short timeline to get these things installed. And Amy Shelton at the time led this effort. And I'll remind everyone that the GBT has 2,004 panels that make up its surface. And there are actuators that move the corners of these panels, 2,209 of them. And there's actually an actuator control room on the GBT structure that tell those actuators what to do. They can move plus or minus 1 inch. And Amy and her team are the ones who designed this and made it work. So there's this huge time crunch, and we didn't have a lot of time. And given the amount of work to test out that system, the telescope operators and some of the astronomers chipped in to get it done on the quick time scale we had. And this was a really Herculean effort because there's one cable that had 12 wires in it, 12 conductors that ran from each actuator back to the actuator control room. And Amy had to make sure that they all worked, that they were connected to the right actuator. And so we had 2 or 3 test jigs that verified that. And there were mechanics from the contractor that would actually wire these things up. So there's 2,209 of those cables. My memory is that there's about 125 miles of cable in that backup structure. And so to put that in perspective, that is the distance from Green Bank to Charlottesville. So it's a lot of cable that's stuck up there.
That's phenomenal.
So one of the issues we ran into is these cables had been up there for a while and they accumulated ice and water, and we couldn't get some of them to dry out. So there were 61 that we had to replace with a different connector head. It was a great project, and Amy and her team did a great job to make it all come together.
That's great. So finding those people in your organization that can help and tackle new things and are willing to take on tasks that might not have been in their job description, but pulling together as a team,
Yep.
It sounds like.
Yep.
Awesome. I hear you might have a little backstory that you can tell us of how it all got started.
Yeah, I have Amanda, I have a favorite story, and that's what we called the first light with the telescope. And again, taking us back to the year 2000, it was a very exciting time. We had just entered the new millennium, lots of apprehension about what everyone's computer clock was going to do. We were in the midst of binding arbitration with the contractor over the structure. So it was legally tense at the time. And our director, Paul Vandenbout, was very eager to show progress. And he was intent on having a dedication ceremony and demonstrating that the telescope worked. And so it was very tense because, again, we knew that we had to get our stuff on the telescope. And one day, this was early 2000, about February, Paul walked in my office and said, "How are things going?" And I knew I didn't have to answer that question because the first thing he always did was he would go to the works area and talk to Martin Barkley, who was the foreman there. And Martin would tell him how things were going. So Paul already knew all the answers before he ever asked me. And I think he was just wanting to make sure that I gave the same answer that Martin did. And so I was giving him my spiel about all these things that we've solved, the problems we had, the progress we were making. And I noticed out of the corner of my eye, he really wasn't paying attention. He was at the chalkboard and I saw him writing down 3 dates. And finally, I told him and he said, "Well, that's all great, Mark." He said, "I want your opinion about these dates. We've got to dedicate the telescope. And Congress is not in session on holidays, and that's Memorial Day, the 4th of July, and Labor Day." And so he says, "Which one of those days do you want to do it?" Of course, I said Labor Day because that was the furthest.
Sure.
I've got a lot of work to do in the meantime. And what was on Paul's mind was he wanted to invite Senator Byrd to this station and name the telescope after him because the senator had been a big advocate for us. But Paul was also trying to address other things. At that time, he was dealing with trying to fund the expanded very large array project, as well as what we know as ALMA today. And it was very important for him to be able to demonstrate that NRAO could get things done, that knew how to manage. And otherwise, he wasn't going to get the money from the NSF to fund these next projects. So he was really keen to make a big statement. And so so we kind of converged on September-ish on when this dedication would happen. I said, "Well, okay, I guess I can live with that." And he said, "Oh, by the way, Mark, I think it would be really cool if we could show that the telescope works. So do you think you could build a receiver that would let us point at a pulsar and you can play it back over loudspeakers?" And
within about a
into that.
6-month period, was that?
That's right. That's right. So this was a new receiver. Fortunately, he didn't want one that was cryogenically cooled. And I kind of said, yes, sir. But I thought, good Lord, I've got so much else to do. I know that I can work this in. So I wasn't really taking him very serious. And so he came back about a month later and he says, how's that coming with that test receiver? And I go, oh, geez, he's really serious about this. I better start working on it. And that's when he said, the date's going to be August 25th. That's when we're going to dedicate the telescope. So that was a hard date.
Mm-hmm.
And so I went down to the lab and talked to Roger Norrod and Louis Beal. Louis was an RF technician, and Roger was the brains of the entire GBT telescope. He was the architect that did the thing. And what's really neat is the prime focus box on the 300-foot, 140-foot, and the GBT all have the same footprint. So if you have a prime focus box on the 300-foot, it would work on the 140 and it would work on the GBT.
Oh,
we
nice.
a bunch off the 300-foot and the 140. So they're the first floor of the Jansky lab was full of them. And so I told Roger, I think, he said, what kind of parts do we have? And he said, I think I can put something together for you, Mark, at 403 megahertz. So he and Louis Beal did that. And so we tested in the lab, was ready to go. Well, later on in the summer, Paul said, we need to see if we can get this thing installed in the telescope. And so I went down to the construction site and asked the contractor if they would let us do that. And they said, we get back to you. And the next thing that happened is Paul got a letter from the contractor's lawyer, effectively saying, no way, no how.
Oh, goodness.
And it was very contentious,
Mm-hmm.
very contentious. And what they were worried about is they wanted to get on with the formal acceptance of the telescope. Paul said, okay, I can do that. So let's talk about how we're going to accept this and, formally and have the handover.
Mm-hmm.
In itself was contentious too, because the road to the site had been kind of torn up. There was the warehouse there. There were walkways under the backup structure that we wanted to have, and who was going to insert the retro reflectors on the surface for our laser range finders. So we all came to terms with that. And Paul was kind of down at one point saying, you know what? I don't think they're going to let us put that receiver on the telescope. Hey, maybe do you and Sue Ann think you could find a tape of a pulsar you could play back, and we'll just pretend that the telescope works. And so those tapes are everywhere. You can find them really easily. That was kind of in our back pocket. And then, so these negotiations kept on going. And on August 22nd, we kind of closed the deal. And after that was over, Paul said, what do you think? Are we going to play the tape, or are we going to actually observe a real pulsar? And I remember telling him, I said, Paul, if we're going to do this, we're going to do the real thing. I'm not going to play the tape.
Sure.
And so that afternoon, I went and asked him again, and they said, yeah, sure, no problem. And what was interesting at the time was the contractor was behind schedule. And so their staff would work during the day on welding and making the latest improvements.
Mm-hmm.
They would leave, and at night, the servo team would come on to test the servo system.
Oh, wow.
The NRAO guys, which was, as I recall, Joe Brandt, Rich Lacoste, and Tim Whedon.
Mm-hmm.
And so at the end of the business day, I went down there and said, hey guys, we want to put this receiver and see if it works. And so Louis and Roger and Dennis Egan and the Gordon brothers, the antenna mechanics, mm-hmm. they installed that receiver at Prime Focus. And I wasn't really very optimistic, because Dave Hogg had told me when he commissioned the Tatel telescope 85-1, he says, Mark, it took me 3 days to find the beam on that telescope. So I thought, there's no way to pull this off. And So the guys got it installed. We wired it up to the control room, which then was in the Alidade room at the GBT. And I told Joe Brandt, point here at these coordinates. It was a calibrator, and the signal was so noisy I couldn't really tell. I was really frustrated, and I said, well, let's just go look at the pulsar anyway. And we turned it over, and boom, it came in loud and clear. We didn't have to hunt for it or anything. I couldn't my eyes. And so that was 3 days before the dedication. We pulled that off.
That's amazing. I've never heard that story. That's great.
It was just miraculous. And then, the dedication is a completely different story, but we did the same thing. We just looked at a different pulsar while the senator gave his speech. It was great.
And it worked again.
Yes.
That's fantastic. I love that. Wow. That's another really great example of people just coming together to make things happen. Yep. That's incredible. Yep. Are there any other stories that come to mind that you might want to share with us about that time?
So it was, after that, we formally accepted the telescope, and they handed it over to us in October. And that's when we launched our outfitting plan. And that's when the crew really showed its stuff. We got that done ahead of schedule. The guys were fantastic. They really put it together. What I'm leading up to is the track story, which I think a lot of people know about. And so we get the outfitting. The next step was to go into the commissioning of the telescope, which is really the first time we really moved the telescope with a purpose. And, we had the general commissioning plan, but people like Ron Madalena, Frank Gigo, Dana Balzer, they did the hard work of commissioning the telescope. And we did this with an idea of supporting early science observations. I think it was March, April. But as we did that, we asked the contractor, hey, the track is made up of 9-inch thick base plate, and at the time, a 2¼ inch wear strip on top. We were kind of worried about how secure that was. And so we asked them to retighten the bolts on these segments around the track. And when they did that, about 25% of the bolts were broken. The heads just popped right off. And we didn't know what the heck was going on. And we decided, well, the contractor said, well, let's just weld some of these segments together. So that's just to hold things down better. And they also figured out they had installed the wrong bolt, so they replaced all the bolts. So they welded up these track segments. I forget how many initially, maybe a couple. And we found out that as the antenna would rotate in azimuth, those wear strips would move with the antenna. That's kind of scary. I mean, that's like the road surface of the highway moves when you drive your car over it.
Absolutely. And so the people at home are aware of what you're talking about. This structure riding on this track is almost 17 million pounds.
That's right. And so that 17 million pounds is distributed over 16 wheels. And so the track moved, and it was popping bolt heads right and left. And
that's so scary.
It was, so here we were working really hard, trying to get our first science observations, and we had a defective track. And then I remember the next step the contractor said was, well, we need to put in some big dowel pins on the end of these strips. And we were going to do a big test to make sure those dowels held it in place. And everyone was very excited because we were all convinced this was going to work. When we did the test, and the dowels just shattered. I've got a sample on my desk shelf as a reminder that, don't put a lot of faith in the solutions you contrive, because nature will prove you wrong.
Sure, that's a good lesson.
The dowel is just in pieces. And so that's when we knew we had a big problem, and the contractor said, you can't move the antenna anymore. And that was a showstopper. We couldn't, the commissioning team was dead in its tracks. And at that point, the contractor didn't know what to do. And we were highly motivated to get this done. And so I called up some consultants, and one of them said, I'll tell you what, I'm not going to redesign this for you. I'm not going to charge you anything. You pay for my plane ticket and I'll tell you what I think. So I did that. I bought this guy's plane ticket. He was in California. He came out and looked at it, and he looked it over, thought it through, said, Mark, what you need to do is double the size and double the number of the bolts, and that'll do it. And so, well, that's the
What are we gonna do?
So I went to the contractor and said, what do you guys think? They said, sure, we'll give it a try. So they did it, and it worked a lot better than before. They were still comfortable with allowing us to use the telescope, but as I think many people know, that was not the final solution.
Sure.
We went back, and I think people after me designed a different wear strip and installed even bigger bolts to hold that down. There was a related story, the infamous pinging of the wheels. You might remember that, Amanda.
I've heard this. Yes, definitely.
Do they still do it?
No, not that I recall.
Okay. So that was the big mystery that actually kind of led to the track. There would be this loud pinging noise when the telescope would rotate in azimuth. We had no idea what it was, and we opened up some of the bearing cavities, and one big problem was the antenna had sat in the same position for about 9 years. And also the contractor had not filled the bearing cavity full of grease. So water had leaked in and rusted out the bearings. And there were 9 that we had to replace. Like you said, a 17 million pound antenna got put up on jacks. That was scary. And they replaced, we didn't do all 9 of them at the time. That was a big deal and really interesting. But
huge.
Obviously, the pinging noise went away, but I never really fully understood the origin of it.
Is there any general advice that you would give to a young person or someone that finds interest in your career path of project managing or just taking on some of these big facilities or these big projects?
I was never formally trained as a project manager, although that's most of my career. That's the kind of work people study to be project managers, go through a professional certification. I think I was fortunate in that prior to getting to astronomy, I was in the military and industry, given a lot of responsibility early in my life. We're all given sort of certain opportunities and very limited ones. And the observatory was very generous with me in giving me those opportunities, be it the job I have now, working on the GBT. And I think the important thing in retrospect is that being self-aware to understand that you've been given an opportunity of a lifetime and to take advantage of that. Service is a big part of it, aligning your career goals with the observatories or the institution's goals. And that's a recipe for success.
That's great. And I find that to be very true for my part in the observatory as well.
I want to emphasize the role and importance of the Green Bank staff. Throughout my entire career, I still find myself calling up the Green Bank folks on the phone, seeking their advice. I've always said this about the observatory. It's, trying to think up things to do is not a problem. It's like a kid being in a candy store, but you only have so much money and there's only so many pieces of candy you can buy. And so there's lots of interesting problems to work on, and one person can be an expert in all of them, but there's always someone in the observatory who has the answer. And the trick is to just find that person. The people in Green Bank never hesitated to help me, not only professionally, but personally. And it's that unique environment that provides that sense of community that you just won't find anywhere else.
Well, thank you, Mark, for all of your time today, for all of the work that you did to contribute to what the Green Bank Telescope is today, and your willingness to share some of these stories with us.
Yeah, Amanda, thank you very much for this opportunity. And I want to say congratulations again to Green Bank Observatory and the GBT. for 20 years of success, and I'm looking forward to 20 more years.